Hello, this is Mrs. Ward, and we're going to begin Chapter 10, Topics in Analytic Geometry. And when we're talking about analytic geometry, we're going to talk about conics. The first section, 10.1, is on lines. We're going to find the inclination of a line, we're going to find the angle between two lines, and we're going to find the distance between a point and a line. So to begin with, we're going to, the definition of an inclination of a non-horizontal line is a positive angle less than pi, or 180 degrees, measured counterclockwise from the x-axis. So this first angle that I have here is the horizontal line, so there is no inclination. So my theta, or my angle of inclination, would just be 0 degrees or 0 radians. This next one is a vertical line going from the x-axis counterclockwise. I see that my theta is equal to pi over 2, or 90 degrees. This third angle, when I go from the x-axis counterclockwise, I know that my theta is greater than 0 because it's not horizontal, and less than pi over 2, which I can also look and see that this is an acute angle. The third one, here's my positive x-axis going counterclockwise. I know that I'm larger than 90 degrees, or pi over 2, but I have to be positive angle less than pi. And this is going to be an obtuse angle. So those are my different angles. So to find the slope of this angle, going back to trig, we know the slope of a line is going to be the rise over run. This is my y, this is my x. So my slope is going to be the change in y over the change in x, also sine over cosine, and that's why we're just going to say that the slope of this line is going to be equal to the tangent of theta. Now, something you have to be careful about is, in order to find the angle, we're going to end up doing the inverse tangent of that slope to find theta. Remembering from trig, when you go to do the inverse tangent, that's only going to be defined in the first quadrant. That will give me all my positive angles. And it's going to be defined in the fourth quadrant, and that gives me all my negative angles, which means it's not going to fit the definition that we had before. That means it's saying that the theta has to be between 0 and pi, because the inverse tangent is actually defined between negative pi over 2 and positive pi over 2. So we're going to have to make some adjustments when we have a negative angle, and we'll go through that in a second. Find the inclination of a line given the equation. So the first thing I have to do is I have to find the slope. So I'm going to look for the slope. I'm just going to solve this in terms of y. So I'm probably going to take the 3y over to this side and have the square root of 3x plus 3 is equal to positive 3y. Divide everything by 3. And I'm going to have the square root of 3 over 3x plus 1 is equal to y. Remember, I'm only care about my slope for these particular problems, so I only care that my slope is equal to the square root of 3 over 3. Then I ask myself, the tangent of theta is equal to the square root of 3 over 3. That's actually a unit circle value that I should know. And now I recognize that as being 60 degrees, or pi over 3. So the inclination of that line is going to be either pi over 3 or 60 degrees, either one. Doing another one. It must be back here. There it is. So is find the inclination of the line given by the equation. Again, I'm going to solve for y. Probably going to throw y over here. So I'm going to have 5x plus 3 is equal to y. So my slope is going to be 5. So I'm going to say the tangent of theta is equal to 5. Don't know this from my unit circle, so I'm going to have to get out my calculator. So I'm going to end up doing the inverse tangent of 5 on my calculator is equal to theta. When I first do that, my calculator gives me an answer of 1.3734. That's my answer in radians. And then to change it to degrees, I'm either multiplying by 180 over pi, or I'm going to use the DD button on my calculator, and in degrees, I'm going to get an answer that's 78.69 degrees. So that's good. When the tangent's positive, that's pretty simple, pretty straightforward. This one, find the inclination of a line of 2x plus 3y is equal to 6. Again, solving for y, I'm going to take the 2x to the other side. So I'm going to have 3y is equal to negative 2x plus 6. Divide everything by 3. Again, for these problems, I really don't need to do the rest of it, but I like closure, so I'll do it. So here, I'm going to end up with my slope being a negative 2/3. So when I put that in my calculator, so I start off with a tangent of theta is equal to negative 2/3. So I'm going to end up doing the inverse tangent. And when I do that, I end up theta equaling, when I first do this in my calculator, I get a negative 0.588, and I'm going to change it to degrees so I have a better visual representation, and that's going to be a negative 33.69 degrees. So this is what's happening when I do this, and I do the inverse tangent of that negative 2/3, it's actually giving me this angle down here. So that's the negative 33.69. But in order for me to do the inclination of the line, I have to imagine that this line continues on. And it does. It goes like that. So I want, what I'm actually looking for is the angle that goes from here to here. So I want the obtuse angle. So to get that obtuse angle, I am actually going to take this negative 33.69, and since I want to go halfway around the unit circle, I'm going to add 180 degrees. And when I do that, I get theta to be equal to 146.31 degrees. So that's going to be this angle here to here is going to be that 146.31. To change this radian, this negative radian, to the proper, I'm going to add pi, because again, I added 180 or pi. And when I do that, the proper radian would be 2.55359. So this is my answer in radians. This is my answer in degrees. Because it's an obtuse angle, I'm going to have to add that 180 to get the correct inclination. Now I want to find the angle between two lines, and here's the formula for the angle between two lines. And that should look familiar to you because I brought this out from your Algebra 2 book. I copied this from your Algebra 2 book. These were your sum and difference formulas that you learned last year. And you want to find the difference between two angles, so the inverse tangent. So you're doing the difference of two angles, the tangent formula. And that's what this is. The absolute value is just making sure that I'm looking at the positive angle because the definition is a positive angle. So let's do one. So you have these two lines. So the first thing I'm going to do is I'm going to find the slope of line 1. So I'm going to say y. Let's see. So I'm going to say y is equal to negative 2x plus 4. So my slope for line 1 is going to be negative 2. For the second line, I'm going to take the y over here, and I'm going to say x minus 2 is equal to y. So my slope for line 2 is going to be a positive 1. Substituting into that formula, I brought that formula over here for you. You're going to take, and it doesn't really matter which one you call slope 1 and slope 2 because of the absolute value. The sign is going to be positive no matter what, so it doesn't matter which direction you do. So I am going to follow the formula though, and I will take slope 2 tangent is equal to slope 2, which is 1, minus slope 1, which is -2, all over 1 plus and 1 times -2. And when I do that, I get the tangent of theta is equal to, this ends up being 3 over 1, no, that's -1, yeah, that's -2, so -1. So this will be slope of 3 over 1. So now I'm going to do the inverse tangent of 3 is equal to theta. Getting out my calculator. So in radians, I get 1.24905. And then to change that to degrees, theta ends up equaling 71.57 degrees. And then the reason why you're doing the absolute value, if I can go back to a picture of two angles, if two angles are intersecting, two lines are intersecting, then I'm always going to have an acute angle that's in between them, the distance between them, and that's why you took the absolute value to make sure that your angle's an acute angle, which means that it would be the absolute value, which because it would be positive. Okay, find the angle between the two lines. So I have another one here. And so here I'm going to find the slope of line 1. So the slope of line 1 is going to be -3/5. The slope of line 2 is going to be 2/9, substituting into the formula. So the tangent of theta is equal to M2 minus M1 all over 1 plus 2/9 times -3/5. When I do that, I get the tangent of theta is equal to 37 over 45 and 17 over 45. The denominators of 45 will simplify. So get the tangent theta is equal to 37 over 17. So theta in radians is equal to 1.1401, and then as degrees, 65.32 degrees. Did I have another one? I don't think I did. Okay, moving on. The distance between a point and a line is you're going to have to write the line in standard form where you have ax plus by plus c is equal to 0. So you're going to set the equation of the line equal to 0. And then you're going to take the absolute value of that and put that over the distance between it's like the distance formula for A and B. So, and when you do that, you're finding the distance between this point here and this point here and this line, and you're always finding the shortest distance, which means you're going to always form a right angle, and that'll become important in a minute. So when you do that, and I find the distance between any point and the line using this formula, I'm always forming a right angle when it intersects that line. So let's go on to an example and do one. Find the distance between the line 4x plus 3y is equal to 0 and the point 0, 2. So I already have the line set equal to 0, which means my A is going to equal 4, my B is going to equal 3, my C, since there isn't one, is going to equal, that's a C, is going to equal 0. Okay, so substituting in the formula to find the distance, I'm going to do the absolute value of A, which is 4, times the x, which is 0, plus B, which is 3. Oh, mess. Sorry. Times my y, which is 2, plus c, which is 0. I'm going to put that all over the square root of a squared plus b squared. So d is going to equal 6. And then this will be 16 plus 9, which is 25 over 5. So the distance is going to be 6/5. Doing the next one, let's try another one that's first thing I'm going to have to do is set the equation of line equal to 0. So I am going to say negative 7x plus 3y minus 11 is equal to 0. That means my A is equal to negative 7, my B is equal to 3, my C is equal to negative 11. To find the distance, I'm going to take the absolute value of negative 7 times 3 plus 3 times the y, which is negative 2, plus c, which is negative 11, absolute value of that whole numerator, over the square root of negative 7 squared plus 3 squared. So when I do the numerator, I'm going to have negative 21 minus 6 minus 11, and that's going to be negative 38. 38, I'm taking the absolute value, over the square root of 49 plus 9, so that would be 58. So that will equal 38, and then 58, I don't think I can simplify that because it's 2 times 29, so now that'll stay square root of 58. I can leave it like that, or I can rationalize square root of 58, square root of 58, and get 38 times the square root of 58 all over 58. Reduce these both by 2, and I'm going to get 19 times the square root of 58 all over 29, and that's going to be the distance. And I'm going to get the application of this is going to find the area of a triangle. So you know, to find the area of a triangle, if I have a triangle and I want to find the area of that, I'm going to take 1/2 the base times the height. That height, remember, has to be perpendicular to the base that you're using. And that's why it's so important that the point, when I find the distance between this point and this line, it's perpendicular. So we're going to use that to find the altitude or the height of the triangle, and then to find the distance between this point and this point will be the base. So that's what we're doing when we find the area of the triangle. I like sketching it out so I kind of have a visual of what I'm doing. So rough sketch. A is 0, 0. B is 1, 5. This is A. This is B. C is 5, 2. So I'm going to have something that looks like this as my triangle. So the first thing it tells me is it finds the altitude from vertex B to side AC. You can find any vertex at any altitude, but they're telling us specifically to go from B to AC. Remember, it's going to form that right angle, so that's going to be the height of my triangle. So what I'm going to have to do in order to do this is I'm going to have to find the equation of the line that goes from A to C. So let's find A and C. A, 0, 0. C, 5, 2. So I'm going to write the equation line. First thing I need is I need the slope between those 2 points. So I'm going to take 0 minus 2 over 0 minus 5, and I'm going to get a slope of 2/5. Then I don't need to find the y-intercept because it's 0. So the equation of this line is y is equal to 2/5 x plus 0, because my b is 0. I need to write this in x plus y plus ax plus by plus c is equal to 0. So I'm going to bring this over. I'm going to have negative 2/5 x plus y plus 0 is equal to 0 if I want to have an a, b, and c. What I might want to do at this point is, it's because I'm going to put it into an equation where I'm going to have a fraction over a fraction, I may want to take this, and I can do this as long as I do it right. I can multiply this whole thing by my common denominator, which is 5. So I can rewrite this as negative 2x plus 5y plus 0 is equal to 0. Now my a is negative 2, my b is 5, and my c is 0. That's a lot easier than working with the fractions. So to find the distance, I'm going to say the distance is equal to the absolute value of negative 2 times the x-coordinate. And remember, I want the x-coordinate of point B, because that's that point up here. So that's going to be 1 plus B times the y-coordinate, which was 5, plus C, which is 0. And this is all over a squared, so negative 2 squared, plus b squared, so 5 squared. So when I do that, I'm going to have negative 2 plus 25, so that's going to be 23. That's going to be d is equal to 23 over the square root of 29. And I'm going to leave it like that because this is just a step in my equation. So that, going way up here, this we just said was 23 over the square root of 29. So that's the height of my triangle. So now I'm going to take 1/2 my base. So I have to figure out the distance between A and C. So the distance formula between 2 points is the difference of the x's. So 0 minus 5 squared plus the difference of the y's, which is 0 minus 2 squared. And that's going to end up equaling 25 square root of 29. So to find the area of the triangle, I'm going to take area of the triangle. I'm going to take 1/2 the base, which is the square root of 29, times the height, which is 23 over the square root of 29, and I'm going to multiply those. And it happens a lot, and there's reasons why it happens, but these two, the square root of 29 and the square root of 29, will simplify, so I'm going to end up with 23 over 2, and or I can write 11.5, 11 1/2. however you want to write it, and that will be square units, and that would be the area of the triangle. So let's do another one, maybe one where I don't have such a nice easy line. So let's go to another one. Here I have a triangle with vertices 1, 4, 4, 5, and 5, -2. I want to find the area of the triangle. First thing I would like to do is do a visual representation. So 1, 4, out there, that's my A. 4, 5, and 5, -2. So my triangle looks something like this. Oh my gosh, it's really bad drawing. All right. I need to pick a vertex. Let's just do the same thing we did last time, and let's stick with our altitude being the distance from the point B. Let's just go B down here, and we'll make that that distance will be our height. So when we do that, I'm going to say, first thing I'm going to do is find the equation between A and C. So to find the equation between A and C, the first thing I'm going to do is going to find the slope. So I'm going to say the difference of the y's, so 4 minus a -2 over the difference of the x's, which will be 1 minus 5. So this will be 6 over -4. So -3/2 is going to be my slope. To find my y-intercept, because I'm not given my y-intercept, I like point slopes, so I'm doing point slopes. So I'm going to do y minus 4, y minus y sub 1 is equal to my slope, -3/2 times x minus x sub 1. So this will be x minus 1, and then I'm going to distribute. Okay, I'm going to distribute the -3/2. So I'm going to have y minus 4 is equal to -3/2 x plus 3/2. And when I solve this, I'm going to get y is equal to -3/2 x plus 11 over 2. And that was me just going on autopilot. I'm going to have to put this in the form of ax plus by plus c is equal to 0. So this will be positive 3/2 x plus y minus 11/2 is equal to 0. To make life easier on myself, I'm going to multiply this whole thing by 2 to get rid of those denominators. So I'm going to end up with 3x plus 2y minus 11 is equal to 0. So my A is 3, my B is 2, my C is -11, and I'm using this point here for 5 as the one. So my distance is going to be 3 times 4 plus 2 times 5 minus 11, taking the absolute value of that, all over the square root of 3 squared plus 2 squared. And when I simplify that, I end up with 11 over the square root of 13. Again, that's this right here, 11 over the square root of 13. So that's my base. Now I need to find, I'm sorry, that's my height. Now I need to find my base, which means I'm finding the distance between A and C. So to find that distance, I'm going to say the square root of the difference of the x's. So 1 minus 5 squared plus the difference of the y's, which would be 4 minus a -2 squared. When I do that, I get the square root of 52. That has 4 times 13, so I'm going to write that as 2 times the square root of 13. So to find the area of this triangle, I'm going to take 1/2 the base, which is 2 times the square root of 13, times the height, which is 11 over the square root of 13. The square roots of 13 will simplify. The 2's will simplify, and my area is going to be 11 square units. Okay, your homework's on Blackboard. I hope this helps, and I will see you next time in class.